So let's focus upon that if you have a rational number, right? And I hope the definition of rational number is clear, that any number that can be represented in the form of p by q, where p and q are integers and q is not equal to 0, is a rational number. So let us see how to determine whether a rational number is terminating, like the decimal representation of the rational number is terminating or non-terminating and recurring. See, one way, that is the obvious way, that you can divide both the numbers and see the decimal representation and call it terminating or non-terminating and recurring. But my question is, how can you determine these without actual division? Say I have a number 2 by 5, right? When you will divide 2 by 5, what will you get? 0.4. Terminating? Fine. The division process gives us the answer. See, I have a number 1 by 3. 1 by 3 is what? 0.33333. Goes on like this. 0.3 bar. Non-terminating and recurring. So the question is how to determine. Now these are small fractions that you can divide. Now say I have a number, say 24 upon 625. Now tell me whether this will be terminating or non-terminating and recurring. So let us see how to determine that. The point is, if a number, right, if a fraction or if a rational number has denominator, you know that a rational number is in the form of p by q. Now the thing is, if it is terminating, a rational number is terminating, this can happen only when q can be represented in the form of 2 to the power of n into 5 to the power of m, where n and m are whole numbers. Okay, that a number p by q can only be terminating when q, the denominator, can be represented in the form of 2 to the power of n into 5 to the power of m, where n and m are whole numbers, right? Only this. If q has any other factor other than this, then it will be non-terminating and recurring. Fine. Let us take some examples so that this will be much clear. Let us take the same case. 24 divided by 625. Now 620, let us concentrate on 625. What is 625? 25 into 25, which is nothing but 5 to the power of 4, which can be written as 2 to the power of 0 into 5 to the power of 4. Condition satisfied, 0 and 4 both are whole numbers, and 625 has only these factors, hence this will be a terminating decimal expansion. If I take another example, say I have 8 divided by 30. Whether this will be terminating or non-terminating and recurring, let us see. Let us concentrate on the denominator. 30 is nothing but 6 into 5. Okay, 6 is nothing but 2 into 3 into 5. So finally I have 2 to the power of 1 into 5 to the power of 1 into 3 to the power of 1. Though these both satisfy our condition, but it has one more factor of 3. Okay, so it cannot be only represented in the form of 2 into 5. Hence this will be non-terminating and recurring. Okay, so the only concept behind this is that if it is terminating, the denominator should be in the form of 2 to the power of n into 5 to the power of m, or else it will be a non-terminating and recurring decimal expansion.